Hi folks, we're going to take a look at page 575, number 7a, and they're asking us to determine the equation of the tangent to this curve where x is equal to 1. So since the tangent is a line, we need to find a slope and we need to find a point. So the slope is going to be given by the derivative of this function, evaluated at x equals 1, and then to get our point, since the tangent and the curve share a point, we just need to find the y value at x equals 1. So let's start with that. So f at 1 is just equal to, well, here the cube root of 1 is just 1 and the logarithm of 1 is 0. 0 over 1, just 0. Okay, so we have our point. Our point then is just going to be 1, 0. Nice and easy. All right, so let's take a look at finding the derivative. Now, before I find the derivative, I actually noticed that I can simplify my life a little here, because let's see what happens if I rewrite this as ln of x to the 1/3 over x, and we see here that we can apply the ski-slope rule. Okay, so that gives us 1/3 ln x all over x, and of course that can just be written with the 3 in the denominator, so this function here can be written as ln x over 3x, which is simpler than keeping the cube root here, because that would mean I'm going to have to use the chain rule when I take the derivative of the numerator. This allows me to get away without ever having to use a chain rule. All right, so this is one of these tricks that if you happen to notice it, makes your life a little simpler. If you don't, you would have been able to solve this problem, maybe with just a couple of extra steps. All right, so I'm going to find the derivative now of this form of the function. So f prime at x, again, still going to have to use the quotient rule here. So derivative of ln x is 1 over x times the numerator function, denominator function, which is 3x, okay, minus ln x, the numerator function, times the derivative of the denominator function, which is just 3, all over, and this is 3x times 3x is going to be 9x squared. All right. So here, I could just stick x equals 1 into here, but let me just simplify just to show how this can be written quite nicely here, because I see the x in the denominator and the x in the numerator cancel out. So I've got 3 minus 3 ln x, okay, over 9x squared. And I could also factor out the 3 here, and I'm just left with 1 minus ln x all over 9x squared, and then these cancel out or reduce to end up with 1 minus ln x all over 3x squared. Okay, so here, even if I had stuck the x equals 1 into the first expression I had, or even this one here, would have been perfectly fine, but might as well just simplify if I can. So that means that f prime at 1 is just going to be equal to, well, 1 minus ln of 1 is 0, so just 1 in the numerator, and 3 times 1 squared is just 3. Okay, so now we've got our point, and we've got the derivative, which of course is going to be our slope. And so now we can find the equation of the line by plugging everything into y equals mx plus b. All right, so our y value is equal to 0, our slope is equal to 1/3, and our x value is equal to 1. Oops, sorry, plus b. Okay, so that means b is just equal to negative 1/3. And so our final answer here is just equal to y equals negative 1/3 x, positive 1/3 x, because our slope is 1/3, and then minus 1/3, which is our b value. All right, now this is in slope-intercept form. The textbook, seems to always give the answers in standard form. So just to recall how we could write this in standard form. So first of all, let's clear out the denominator so we can multiply both sides of the equation by 3. So we end up with 3y equals, here the 3 is going to cancel out, so just x minus 3 is going to cancel out again, so 1. And so my final equation is just x minus 3y minus 1 equals 0. And also acceptable if I bring the 1 to the other side. All right, so just to recap this question here, first of all, because we were looking for the equation of a tangent, we needed a point and we needed a slope. We had the x value. We could plug it into the equation of the function to get the y value. So there's the point that's on our curve and our tangent. And then we found the derivative to determine the slope. And once we had that information, we can just stick everything into our linear equation and determine our answer. Okay, that's it for this one.